Is it working? Okay, so hello. Today I will be talking about who supervises supervisors, which is about high-level supervising of your virtual machine. So it is an idea of Erlang supervisor one step higher in the or lower in the stack. Who am I? I am Erlang Elixir, an Elixir developer at GmbH. I also am part of Erlang Ecosystem Foundation Observability Working Group, where we are working on OpenTelemetry, telemetry, and overall observability of applications written in Erlang and our other languages of ecosystem. I am also an author of systemd Erlang library, and which is also usable in Elixir, and few other libraries that are not much popular, but I find them quite useful, at least for me. If you want, there is a link for my blog where I sometimes, from time to time, I publish some of my thoughts. So first of all, there is some knowledge needed. I will not explain to you what are OTP supervisors. I will not explain what are OTP applications. I will not explain exactly how OTP or systemd works. Or in general, I will not get into the detail. I just will be operating on quite high-level ideas of supervising processes and applications. Another important thing, systemd is okay. It is not perfect. It is okay. So if you want to start a flame more about using systemd versus using runit or using whatever is Gentoo using, just don't. Systemd is okay. It is not perfect. It has some flaws. Everybody know the flaw. Most of people know the flaws, and in this talk, I don't want to start any flame war between the people in favor of systemd and against the systemd. It is just a talk about how to use systemd with Erlang. So our talk will have some parts. One part is what is an init system in matter of Linux systems, and how it is special in way of from other processes. It also explains a little bit how this works on high level and what features it need to have and what features it provides. Next, I will talk about some systemd features that are interesting in Elixir and Erlang world, where we are writing mostly applications that are connected to external world via sockets. How we can use these features, and that mostly how it works. So on high level, a little bit lower level, ideas how Erlang works. In Erlang, we have one dedicated process which is started each time when the virtual machine is started. It is Erlang init. It is, in a way, it is special that when this process dies, everything in our virtual machine dies. So it is. And another thing which it does, it reads and start applications which were provided to it. So it works exactly like this. So it reads, starts application number 1, application number 2, application number 3. And what we will be talking about today is neither of this. We will be talking what is above the our Erlang init process. So the process that is supervising our main supervisor. So the important thing is the init system of Unix systems. It is first process that is run by our operating system ever. When we start machine, then this process will be started, and it is responsible for starting any other processes that we will then will be using. So this run with special process identification number 1, which you can see when you run ps command. It also is important that it works similarly to our Erlang init process. When this process goes down, then whole machine will stop functioning at all. In modern OSs, in modern implementations of operating systems, it also will halt the machine. But if you are old enough, you can remember when there was a screen when you are shutting down the Windows 95 or 98, where now you can safely turn off the computer. And this is what was happening when the init process went down in Microsoft Windows. It is responsible for everything, for setting everything else, and it is very important in Docker world. It is responsible for reaping zombies, which are processes abandoned by their parents, which are practically defunct, and the init system is like a reaper who just kills unwanted childs. However, it sounds terrible. In systemd, the process which starts as a process identification number 1 is also the system supervisor, which is the process which starts all other processes in different init implementations. It behaves differently. Where, for example, I believe run it, the main process is just starting another process that is running all other processes, and this has some. In some cases, it is better. In some cases, it is worse than the starting everything as main process on system. The similarities between our Erlang and system init. As I said earlier, when it dies, it dies. Everything shuts down. In case of Erlang, the virtual machine goes down. In case of system init, whether it was running, whether it is container, whether it is a virtual machine or whole physical machine, it goes down. As I said earlier, it starts everything else. As I said also earlier, it reads configuration, then start required jobs. In case of Erlang, these are app files. In case of systemd, there are special system file service files, and also different or other jobs specifications files. It listens on the messages to start and stop the machine. And why we should bother? Why it is important for us to use the system supervisor and not just start process and call it a day. The important things are top-level process management, which allow us to order our jobs in reasonable way, to have startup that is behaving correctly. For example, we need to start virtual we need to have internet connection before we start our Erlang application. We need to, for example, start the database before we start our application, because for some reason we run database and application on the same machine. We need to do many other stuff that is required for our application to start, and we need to order them in correct way. So systemd is keeping us from is preventing us from having race conditions when some application start before its dependencies start. It also restarts our processes when they die. It's similar to what Erlang supervisors does. So even if our Erlang virtual machine dies, then it will be restarted, and we can treat our whole virtual machine in the same way like we are treating the supervisors tree in OTP. However, we should not rely on this one as much as we rely on supervisors trees in Erlang. It allows us to have startup shutdown hooks. While in Erlang, we also have similar possibility via applications callbacks. This one, for example, allows us to fetch configuration from external source and save it as a sysconfig file, which allows us, for example, to define how will Erlang distribution work, which is not possible once the virtual machine was running in Erlang. You cannot change some of its configuration, so you need to load that configuration before the application and the virtual machine will ever start. In Elixir world, it is tried to be done via reloading configuration, and it was called configuration providers. But to be honest, I think that relying on external system that will manage our configuration for us is way better, because it makes the startup process of our application much easier. It also allows us for isolation and hardening of our running processes. For example, we can remove or add capabilities to the virtual machine. We can create virtual users that are existing and working on and are visible only for our current process. We can do stuff like isolating, removing capabilities from our process to write all other stuff on our system. We can even prevent it from reading stuff from our system. We can create virtual and temporary temp directory in file system tree. It allows us to configure and mostly restrict our application to very narrow set of capabilities that we require it to work. We also have possibility to limit resources that are available to our process. For example, we can reduce the amount of CPU time which is allowed for our process. We can create memory limits, virtual memory limits, physical memory limits, any kind of what we want. We can even reduce an amount of ports which will be used, or file system sockets. So, for example, if we know that our application will be not connected from the, will be not accepting connections from the outer world. We can limit it to what we know, which will be used as the hard limit for file descriptors, and then it will cause that any unnatural behavior, like creating more file system, more file descriptors than it was allowed to, will cause the process to be killed. It also allows us to monitor state of the system, which in this case, we with one command, we can check that our database is running, that our applications is running, and everything should behave okay and should be safe for, and we should assume that the machine is working mostly correctly. It also gives us a centralized log management, which many people is problem when using stuff like Lagger or Elixir logger, when you are trying to save your logs to a file, and for example, you forgot about log rotation. So all systems in all processes in our system send logs to a single place. So we have, when something is wrong, goes wrong, we have one place when we can check all the logs from all subsystems in our application, in our whole system. It also solves our problem with manual log rotation, where because it will rotate logs for you. You just throw logs at the system and you just pray that it will log correctly and store that messages in single place, and it will rotate it for you. Another interesting thing is keeping metadata together with logs, which is often very underappreciated things, as in textual logs, we often forgot about metadata, which I have seen a lot of times in Elixir world. The metadata are important because they do not only tell us what is happening in our system, but also where it is happening, and it allows us to have more information in form that is easier for the computers to parse, which allows us then to, for example, we can filter. We know that on this we have 3 or 4 machines where our applications is running, and we can limit it to in our, for example, Datadog or Kibana or whatever you are using for storing messages in a more centralized way. You can just filter them out and check which logs are coming from this one machine or the other one machine. It also have a built-in log dispatching tool, which allows us to use journald as a for simplified version of Kibana or Logstash or any other tool that you are using for dispatching your logs to different system. This is useful when you have highly distributed system and you want to gather logs from different systems, and for example, gathering metrics from the log metadata. So this is very useful tooling that in case of using other tools, it is a little bit harder, not always, but in case of journal.d, it is just another system of systemd, which is quite very easy to set up and just dispatch your logs somewhere else. It also very easily connects to, it is very integrated with systemd. So if you are using your standard tools, like for example, you are using default Elixir logger backend, then it will automatically attach themselves to standard output and standard error of running process, and will gather all that information as logs. You can also use a special format to make them to make the journal.d aware of the log level and stuff like that. But in general, in Elixir application, you just start it and it will work out of the box with gathering all your logs. So even if you forgot to add some file backend or something like that, you will also get all your logs. It also have another way of logging, not via standard output, but directly logging via Unix socket, which is useful when you want to have more information, when you want to add your own metadata to logs, when you want to have multi-line logging, which is very useful for example, for error logging and stuff like that. So unfortunately, for some people, the logs are stored in binary format. This have advantages, this have disadvantages. As I said, we will not discuss it further, but it just need to be remembered that you are forced, if you are using journal.d, you are forced to use their own command line tool for reading the logs, as you cannot just open them in less and read them right away. This is sad, but it has also some advantages in this format. Mostly because the most important advantage is that you have support for multi-line logs, and it is possible to keep metadata together with logs. And metadata don't need to be fully text. You can use the binary formats or just numbers as well. So how you use it? In case of using my library in version, very simple, when you are using Erlang logger. Unfortunately, this isn't fully working that way, but it will be working that way. It just attach itself to system tool. Erlang logger changes its output format for the format that will be more understandable by the journal.d, and that's it. In more complex way, which is currently suggested way for using systemd with Elixir, you just add one more function to application, start callback, and magic. It just will work and will store your logs with all metadata that you need, like process ID, Erlang process ID, current function, current, I believe, yes, current function, current line, file, and stuff like that. All the metadata that you have in your Erlang, in your Elixir logs will be available there. There is also system for notifications and watchdog. Watchdog is like Erlang heart process, which is not used enough. It is process that checks if your Erlang virtual machine is still working and it's still responding for the pings. And if it is not responding, then it will restart it automatically. And Erlang, systemd also have similar subsystem, which I believe is easier to use for the reason that it is available for any other processes you are using. So via notifications, you can inform your operator, system administrator, or whoever is checking on your application about the state of the process. So you can inform that the application is starting. You can, after some time, it will notice that it already started and it is ready to go. Or you can just inform that you are stopping and the application will be shut down soon. As I said, watchdog allow you to check whether the system is still alive, and in regular it requires application to send notifications in regular timestamps to check whether it is still responding or not. And if there is no message in required time, then it will just restart the application and hope that after restarting it will be working as expected. You can also trigger restarts from within an application, which is by sending a special watchdog message. You just tell the systemd, okay, this application should be restarted. As soon as you are able to do it, do it. So send the signal to the application, which will force it to stop. Then the application will go stopping, and if it stops, then it will be restarted, and if it not stop in a required time, then it will be forcefully killed and then start again. And quite important thing for us, but it is not working fully right now, which I will be talking in a moment, is storing open-end file descriptions like sockets. So when you are restarting your application, you can keep all your connection open between the restarts, which is important for us for stuff like WebSockets. So the client will never see that he was disconnected from your server. It will be still running, still open. Just there will be, of course, a delay in the messages, but the application will never. The user will be not disconnected from your application. And how to use it? This is just it. You add, of course, you need to add systemd library to your dependencies, and then you add systemd ready call somewhere in your children list. Of course, after you are assuming that your application is in state that you can call ready, where you are already accepting connections, when you are keeping all stuff done. It is important to point it there that this one will work even if there is no systemd. So if you are at this library and to run all the stuff that are and add this systemd ready, then it will work even if you are starting application on systemd, on the system that is not using systemd, for example macOS, or you are just starting your application from command line without any systemd connection. So this will allow you to make your application systemd aware, but in a way that you are still able to use an application in any other way you were using it earlier. So it allows you to gradually start using systemd. About the watchdog, if you are at special line in your service file, then it will automatically detect that there should be a watchdog process running, and it will start process for you that will message all, will send the ping messages to the systemd in required intervals, making sure that your application is fully running and alive all the time. Ooh. And the thing that's made me to create this library, and also the nicest thing in using systemd with Erlang, is that there is a lazy startup support, so also called a socket activation, which works like that. The systemd opens a connection TCP port for you, and then pass a file descriptor to your process. So as soon as your system starts, it will accept all requests that arrives, which is, for example, important when you are using load balancer with dynamically attaching the virtual machines. And the process will queue for as long as you are as you need to until your application started, and then the application will process all requests that arrived in meantime. It also means that your applications will start only if the request arrives. So, for example, if you are starting your new virtual machine and there is no users right now, then your application will not start at all. It will be still running. It will be waiting until the first request arrives. It, as I said, it opens sockets as soon as the system starts. So you are not there. So when you are using load balancing, which are not health checking or something like that, then it will just open as soon as possible, and the request will be, and it will be possible for requests to arrive, and it will queue as long as needed. As with notifications, it keeps sockets open between application restarts, so you can restart your application, and systemd will keep your socket open for you in the meantime. So all requests in between will arrive. There will be no message for the user about the disconnection, and it will just queue in the meantime, which is a little bit useful when you are using in-place hot reloads. Another very important thing, which is, I believe, in Erlang world is the most important thing, is that you can create privilege. You can open ports on privileged ports, which is, for example, 80 port for HTTP or 443 for HTTPS without super user. So you will be able to run your Erlang process as a main process that is opening the port 80, which means that, for example, you will not need engines or whatever reverse proxy you were using for capturing or for listening messages from the void. So you will be able to remove one layer of applications between your application and system and external processes. This one also means, of course, you could use, for example, Linux capabilities to allow your process to create sockets to open sockets which are under 1024. But the problem is that it will allow you to open all them or neither of them. There is no, I want my applications to be able to open only port 80. So if attacker somehow finds a way to run code in your application, then they will be able to open port 22 and just SSH to your virtual machine. And then you are totally screwed. Without that, you can just open all the requested the sockets for your application, and your application will be, and remove any other capability to open any other port. So if you are, for example, using a local database, then it will open sockets from systemd will open sockets, and your applications don't need to bother any other opening or stuff like that. How to use? Unfortunately, this is not as easy as earlier presented stuff. This one requires some stuff to do on the OTP side. For example, the most important thing is that currently you cannot create gen TCP process from already opened and bind socket, which is quite unfortunately, but I am working on it with an OTP team to make it possible. It should be possible when the socket implementation, which is using NIFs, will land. Currently, it is supported for Gen TCP in OTP 23, but I see a bright future when we will be able to also allow other processes to be, other kind of sockets to be managed via the same system. So then I hope that it will be quite easy to make. I have example with proof of concept of making it work right now, but it requires some hopping between different kind of sockets. So first we need to make systemd to open TCP socket and translate it into Unix socket. Then this Unix socket needs to be passed to the Erlang application, which in the end will be listening on that Unix socket, which is quite troublesome, and I am still trying to make it fully work. But for example, it will drop every first request. You need to open your site, then you need to restart the application, restart the connection, and it will work on the second try. So this is not yet here. I am still working on it and trying to make it work as expected. And that's it from me. If you have any questions, then I believe we have some kind of application that will allow us to ask me questions. So feel free, and I will try to answer as many as I can. Thank you.
Yes, so exactly. When it comes to the questions, I would like to let you know once again that there is a Slido in the description of the stream that you could use to ask the questions to Łukasz, and I'm not sure if Łukasz actually sees the question at the moment.
Yeah, I see.
Okay, so I think this is the great time to answer because there are at least 3 questions, I guess, right now.
Yes. So first one, I believe they go top to bottom or bottom to top.
I don't have any strong preference, but one thing I would like to ask you is to read it out loud. Okay?
Okay. So I will go out top to bottom, and you said we shouldn't depend on the system D as much as Erlang supervising. Why? Are the guarantees different? No, not the guarantees are different, but the problem is that system T is you shouldn't allow your virtual machine to die. It is like last bastion of your application. So it is when everything other fails, then it should happen. But it can happen, but in general, you don't want it to happen. So if there is a lot of restarts by systemd in your application, then probably you are doing something wrong. Another thing that is important there is that the starting whole virtual machine of Erlang is quite slow. In contrast to restarting Erlang processes, restarting system process is quite heavy stuff to do. So it will take time, which in most cases you don't have to make it work. Second question is, wouldn't journal D be a better name for a logger handler? Yes, in fact it is called systemd_journal_D. So in general, my idea for the library is not only to be a logger handler, but to be a whole system for making your application work nicely with systemd. So if it would be just a systemd journal-D handler, then probably yes. But in this case, I thought that the name systemd will be more general. It will allow more stuff like socket activations and notification and watchdog. So I picked the name systemd. Third question from Kamil. How does the communication between the Erlang VM and the systemd work? Is it using socket as standard output or some other magic? Just Unix socket. It works just like that. Almost all communication in systemd is via Unix socket. In future, I think I will also create another library for that one because it will be much heavier. Will be systemd dbus, which because systemd is using dbus for most of its communication. So if there will be an implementation of dbus in Erlang that will be working nice with systemd, then, for example, you will be able to start another process which will be handled by the systemd from within the Erlang VM. So it is just sockets. And next question from Anonymous. How does your library place itself with Docker containers? My idea is with systemd you don't need Docker containers. There are systemd containers. It is called, but I think systemd and spawn. which is similar to Docker in the abstraction, but in general, like I said, with the isolation features of the systemd and stuff like that, you just don't need the Docker. It is all there. Docker with its client-server architecture have some problems with managing services. For example, you can, just like in any other network stuff, you can send a message, you can start a Docker process, a Docker container. It will respond that it started, but soon after it will die, and you will never know until you are adding some more information about the monitoring. In systemd, when you are using notifications, when you start your application, and it will block until you send that, okay, I'm ready for work, and just send me stuff more. So I think we can just drop Docker with proper systemd isolation.
Okay, so this is the very, very last chance to ask a question. And if we do not have any more questions, and I don't see any, so I guess that means that everything is clear. And I would like to thank Łukasz for his time and sharing all his knowledge in regards to his library and a couple of other things that he enlightened us about today. And I would like to remind you that we will be having another meeting in about a month. So please do follow us on Twitter, and you will be kept up to date. So yeah, there are no questions. So Łukasz, thank you very much for your time. Thank you, everyone.
Thank you too. I hope we'll see in future, maybe in person, when the whole stuff with virus and stuff will end.
Yeah, that would be great. We are all missing that for sure. So
yeah,
thank you, everyone. Have a nice evening. Bye.
bye.